For part A here in problem 79, finding the domain, we want to make sure we set the argument greater than 0, and the only way that the 2x is greater than 0 is if x is greater than 0. So we would have a vertical asymptote at x equals 0, so basically the y-axis. And the interesting thing about this function is we have a 2x here instead of just x plus or minus a number. And that means that whenever 2x is equal to 1, we're taking the log of 1, that would be 0. That would give us our x-intercept. So when x is equal to 1/2, we have an x-intercept. So if that's 1, then we have 1/2 right here. So the bottom line is this graph looks exactly like the regular graph, the parent function y equals log base 10 of x. But instead of having 1, 0 as the x-intercept, we have 1/2, 0 as the x-intercept. So there's the graph. We have the domain of the function would be all real numbers x, such that x is greater than 0. So there's our domain. We've shown the graph. The range is always all real numbers. There's never a horizontal asymptote with a logarithmic function, but we do have a vertical asymptote. We already talked about that being the x or the y-axis, x equals 0. And then to find the inverse of f of x, we go through the process of letting y equal f of x, and then we flip-flop the x and the y. So I'm going to do all that in one step. We have x equals 1/2 times the log of 2 times y, and so therefore after multiplying through by 2, we get 2x equals the log of 2y. And at this point, I need to get at that y. I have to solve for y, and when we solve for y, we get f inverse of x. So solving for y, I have to convert this equation to exponential form. And the base right here, since it's log, we don't see a number there. It's implied that that's a 10. So we rewrite the same equation in exponential form. 10 to the 2x is equal to 2y. And then let's move it up here. If we divide both sides by 2, we get y equals 1/2 times 10 to the 2x. Well, 10 to the 2x does not have a horizontal, or doesn't have a vertical shift. So therefore, the horizontal asymptote is y equals 0. And if x is equal to 0, y is equal to 1/2. So again, when we have a function and its inverse, we should also put this here, f inverse of x is equal to 1/2 times 10 to the 2x. And don't you dare put 5 to the 2x, because we have to rate. You can't multiply the 1/2 times the 10 if the 10 already has an exponent. So 10 with the exponent just can't multiply that by 1/2. Doesn't fit the properties of real numbers. Anyway, what was I going to say? Oh, 1/2 comma 0 is the x-intercept for the log graph, 1/2 times the log of 2x. And then that would mean that 0, 1/2 is the y-intercept of the graph of f inverse of x. And so we're going to go ahead and draw the graph. 1/2 times 10 to the 2x. And then that would be just symmetrical with respect to the line y equals x. And let me put f inverse of x equals 1/2 times 10 to the 2x. And this, I should have put this as f of x. So we've graphed f of x. The domain of f inverse, graphed f inverse. Domain of f inverse is all real numbers, and the range of f inverse would be all real numbers y, such that y is greater than 0. And we found f inverse of x. And let me go ahead and put a red box around that. There's f inverse of x. So that's it.